Hi everybody, welcome back. This section right here, this little screencast isn't really part of our notes, although I thought maybe it would be helpful to you to kind of understand weight a little bit better. Maybe it should be part of the notes, I don't know. But we've talked about weight. We write it as, sometimes we write it as W. We write it as the weight force like that sometimes. In fact, a weight really is a force, right? It's not anything else. It's a force as being equal to something's mass times the acceleration that it experiences. Right? In this case, well, if you're on Earth, your weight, or you might say your apparent weight is equal to mg. Right? We've been writing that this whole time. We have a person right here, and they have a center of mass. All right, and that person's center of mass is being directed downwards because their mass is being accelerated by gravity, and so therefore they have some sort of weight force. That should be an uppercase F. All right, they have some sort of weight. All right, well, what determines if they have some sort of a weight? What do you do to determine if you have some kind of a weight? Well, you step on a scale. All right, so let me draw this person again, right here over to the right, and they have some sort of center of mass, but they are standing on, let me draw a brown scale right here. All right, it's a bathroom scale, and it has a dial on it and all that stuff. All right, that's pretty terrible, but you get the idea, okay? That scale, what it is doing is it is supporting them. Okay, so we can say your weight, or your weight force, is really, you might say, your apparent weight. Your apparent weight, it can also be thought of as being the supporting force. All right, the force that is supporting you, because after all, here you are, your mass is being accelerated downwards due to gravity, right? mg. Why does this scale right here register something when you stand on it? Here, I'll give you some longer legs right there. And there, now you're standing on the scale, okay? Why does that register something? Well, because it is applying an upward supporting force. That prevents you from what? Well, prevents you from falling through the floor, right? Now, hopefully there's a floor there as well, and the floor is supporting you. But that scale, since that scale has to apply a supporting force, that scale has electronics or machinery inside of it that measures what that force is and gives you a readout. Hey, you have a weight of X number of pounds or X number of newtons. Okay, so all these ways of thinking about weight are true. It just may be more helpful to think about it as one way or another. Your apparent weight, or the supporting force right here. All right, what if you were in an elevator? Okay, you're in an elevator, and I'm going to make that a different color elevator. All right, I'm going to make that a green elevator, and you are at rest. Okay, so here's you. And I'll give you some longer legs right there. All right, and you're standing on a scale. So there's your scale right here. So at rest. You have a mass that is being directed downwards. And therefore, since the scale is supporting you, right? It's supporting you. Therefore, it is applying a force upwards. We'll call it the supporting force, so you might call it your apparent weight. All the same thing. And so therefore the scale is feeding back and is giving you some sort of measurement on what your apparent weight is at rest. Right there, all right? And so if you're inside an elevator and your weight is the same that it usually is when you're on solid ground, you can determine that you're at rest even if you can't see out of the elevator. Okay? But let's say, for example, what were to happen if you all of a sudden were inside of an elevator and you were weightless. All right, here's your scale right here. The scale is also weightless as well. How do you know you're weightless? Well, the scale registers 0 newtons. Awesome. All right, the scale is not supporting you. The floor is not even supporting you either, because otherwise you would feel some sort of force in the bottom of your feet, right? Some sort of supporting force. So the floor is experiencing a supporting force of no newtons, right? Because it's not supporting you. Nothing is supporting you. There is no supporting force. All right? Therefore, your apparent weight is 0. Okay? So for you, even though you still have mass and you are still being accelerated by gravity, your apparent weight, or the supporting force, equals 0 newtons. Okay? Well, if that's the case, if you're inside an elevator and you find yourself floating, that is, having no weight, what is happening? Well, you can conclude you are no longer at rest. Rather, you can conclude that that whole system is doing something. If you haven't figured it out by now, that whole system is accelerating. It's accelerating downwards, right? And in fact, if you find yourself weightless in an elevator, it's a very bad thing, because you are basically free falling. Right? The elevator, the cable has broken, and you are enjoying weightlessness. Hooray! Inside of an elevator. Well, that's bad, because at some point you have to come to an abrupt stop, and that'll probably kill you. But the point here is that weight is perceived. That is, it's the apparent weight, or it is the measured supporting force. If you have no supporting force, no supporting force either by the floor or by the scale or whatever, then that means your whole system must be accelerating. And you happen to be accelerating at g, or 9.81 meters per second squared, downwards. All right? So weight can be thought of as being the supporting force that whatever is holding you up is applying. Okay? I hope that helps. That's one way of looking at this. What we're going to do in future problems is I'm going to talk about weight. In our notes, we just called it W or FW. We'll talk about weight as being kind of like the apparent weight, or what is that supporting force. All right, that supporting force varies depending on what your system is doing. At rest, your weight is always mg, right? Because you're not accelerating. But if your system is accelerating, then that will cause your apparent weight to fluctuate, either become much lighter such that you are weightless, or you may have noticed that if an elevator goes upwards, you actually feel heavier. You have a greater apparent weight. That will determine what your weight is, will determine what the acceleration of that system is. So that's it for now on weight. And now we're going to take some of those applications, or some of those principles, and apply them to problems. Hope that helped. If you have any questions, come see me. Thanks for watching. I'll see you on the next one.